In this first section, we're going to discuss components of soil. Soil pollution and water pollution are an issue all over the world. These two types of pollution occur together because polluted water will contaminate soil and polluted soil will contaminate water. Soil pollution is a concern for people and the environment. It damages fragile ecosystems, alters landscapes, and affects the quality of crops and agriculture. There are many ways to reduce soil pollution and remediate contaminated soil. Soil's functions include providing a medium for plants and fungus to grow, providing a habitat for microorganisms as well as animals, storing water, storing atmospheric carbon dioxide and other gases. The functions of soil vary depending on what type of ecosystem it is found in. All of soil's functions can be negatively affected by pollution. Let's now start discussing the components of soil, beginning with the layers of earth. Soil is part of a covering of loose, rocky particles called regolith. The regolith covers the underlying bedrock. The weathering of bedrock, combined with organic matter from microorganisms, plants, and animals, all contribute to topsoil, the outermost layer of soil we typically think of. Topsoil is the layer that is important for the growth of plants. So we have labeled here each layer. Here is the topsoil, the regolith without the organic matter, and the saprolite, which is just less weathered regolith. And below that is the bedrock. The composition of soil varies, and it is affected by the surrounding ecosystem. Typically, soil contains 50% solids, which you see on the right side of this pie chart, about 45% minerals, so like sand, silt, and clay, and another 5% organic matter. The other 50% is voids or pore space, things like water and gases from the air. Sources of mineral components in soil. Mineral components of soil come from a parent rock that is weathered down, either eroded or ground into smaller particles. The mineral particles from the weathered down rock take the form of sand, silt, or clay. The properties of sand, silt, and clay in a sample of soil determine the soil's texture. Sand is the most coarse. You can see it in the image on the top right. Sand particles are between 0.05 millimeters and 2 millimeters in size and can be seen with the naked eye. Sand has a gritty feel. Silt, the next sample here, is finer than sand, and its particles range from 0.002 millimeters to 0.05 millimeters in size. Silt feels like flour. And finally, clay particles are smaller than 0.002 millimeters. Clay feels sticky when it is wet. The images on the far right here will show relative sizes of the particles. So if this pinpoint is clay, you can see how much larger a silt or sand particle is in comparison. In this table, we can see a summary of the sources of the different soil textures and the properties that those textures allow. In our first soil type, sand, we get the sand from things like beaches, deserts, and along rivers. And the properties of sand are low water holding capacity that permits water drainage. Silt is found in areas of flowing water, such as stream deposits and lake beds. It is carried by wind and blown into areas away from their sources, also formed by farmers as they plow their fields and further erode the soil. Silt has more water holding capacity than sand, but less water holding capacity than clay. And finally, clay is found where water once flowed, such as areas where glaciers passed over and dried up lake and riverbeds. Clay has the highest water holding capacity and it has the ability to bind nutrients. Let's discuss now the mineral composition of soil. The primary minerals found in soil are feldspars, micas, iron oxides, and carbonates. So in the images, we can see the rocks of potassium feldspar, iron oxide, and a calcium carbonate. These minerals provide nutrient-dense elements for plants, including potassium, calcium, sodium, magnesium, iron, zinc, and many others. The rocks shown below will provide mineral nutrients to plants when ground up into very small particles and mixed with moist soil. Sand, being coarse, contains limited mineral nutrients for plants. This is why you do not see large forests growing in sandy areas. However, smaller plants such as grasses, shrubs, and sometimes larger cacti and other plants that do not need high amounts of mineral nutrients can grow in these areas. Clays form the most fertile soil for plants because they hold more water. Clay's small particles have large surface areas that store nutrients and provide them to plants in a soil water solution. Organic matter in soil refers to anything found in the soil that was once alive. This includes the decaying remains of plants and animals, as well as their waste products. Organic matter is important for soil because it contains nutrients that are used by plants and small animals. It also allows water to filter into the soil easier. The soil shown below and to the left, right here, contains more organic matter than the soil on the right. Characteristics of soil with high organic content include dark brown or black color, feels moist but allows water to drain, loose and not compacted, and easy to scoop with your hand and holds into a ball shape when pressed together. How is this organic matter formed? When living things die, shed parts, or excrete waste, decomposition occurs. Microorganisms in soil, including fungi and bacteria, are responsible for decomposition, and they form something called humus that cannot be broken down any further. Decomposers are essential to every ecosystem because they allow nutrients to be recycled from the once living organisms to new life. This decomposed organic material in soil is called humus. Fertile soil is soil that has large amounts of humus and therefore nutrients that support healthy plant growth. Let's dig a little more deeply into what is in this humus. Humus is the final product of the decomposition of material from living things. It makes up about 5% of soil. If you go back to the pie chart from the beginning of this section, that's the organic matter component. Humus itself is not rich in nutrients. However, it is able to attract cation positive and anion negative nutrients with weak bonds. The humus will release these nutrients into a soil solution, which are then absorbed into plant roots. Humus is also food for small animals, including earthworms and insects. These animals help to aerate the soil by creating voids that allow movement of water and nutrients throughout the soil. Charcoal is formed when plant or animal material is heated up in a low oxygen environment. Charcoal is made up of mostly carbon that was left behind by molecules in living things. Charcoal is highly stable and can remain for thousands of years. Biochar is the name given to charcoal that is used to improve the health of soil. Because biochar is porous, it helps soil retain water and nutrients. Biochar is currently being investigated as a way to reduce climate change. Biochar is formed from plant material that captures carbon dioxide in the air. Once biochar is in the ground, the carbon will not become carbon dioxide again. Aerated soil. 50% of a given volume of soil is empty space. Of that empty space, half of it contains water and half of it contains air. The result is a moist and light consistency. The aeration of soil is achieved by earthworms and other small animals that create passageways in the soil that allow water and nutrients to move through.